Hi all, today I will be doing this counting bits problem. Problem states given an integer n, return an array answer of length n plus 1 such that for each I in the range 0 to n, answer I is the number of ones in the binary representation of I. So what they want basically is, let me erase this. So what they want essentially is if n is 2, then they want number of ones from 0 to n, that is number of ones in 0, number of ones in 1, number of ones in 2. Similarly, if n is equal to 5, they want number of ones in 0, number of ones up to number of ones in 5. That is, yeah. So to solve this problem, you need to basically know the relation that number of ones in even number is equal to the number of ones in the number which is half of that number. So see this 4 has number of ones 1. Similarly 2 also has number of ones 1. So we can come up with this relationship that if n is even, then let's say num of ones in n is equal to num of ones in n by 2. Oops, n by 2. So n by 2 basically this is integer division. That means if 5 integer division 2, that is this sign, it will return 2 instead of, if we would have used this, then that will result in 2.5. So I will be using this double division. And similarly, if n is odd, I will just copy this up to this. Okay, this should be is equal to, this should be is equal to, it will be like 1 plus, so it will has extra 1. So let's take the example here. So 5, you can see here 5 has extra 1 than this 2, so that it is same. Okay, so once we know the relation, we can code, and code is very simple. What we will do, we will declare this list, and then we will populate this list. It's from 1 to n plus 1, because we already know the value of 0, that is number of ones in 1 is, sorry, number of ones in 0 is 0. So since we have initialized a whole list to 0, location 0 of that list will have the number 0. So res I will be, that is result, ith location of the result will have the value. We will write this helper function, but assume that it will return that value to this location, which will be like I, and last step is return that result. And let's define that count bits, let's call it helper, therefore we will call h. So let's write this function. Oops, accidentally opened Excel. Let's call it n. So if n is 0, we know that 0 is the answer. Else if that integer is even, we know that we need to return the result of this. Else we need to return plus 1. So let's run this. let's submit this. Okay, this solves the problem, but you can further optimize it by memoization. Why we are doing memoization? Because suppose that n is 64, then to calculate 64 you will call according to this, right? You will call 32, 32 will call 16, 16 will call 8, 8 will call 4, 4 will call 2, and so on. And since our array, that is this result list, sorry, since list is getting populated from 1 to n, so 64 to so we will reach 64 after calculating 32, 16 and all those things. But if we follow this code, then this code will compute that thing repeatedly, so we don't want that. So we need to memoize. So for memoization we will just declare this a memo object, which is very standard. Memo, in this case list. I will just put here memo. So I will explain how it will not uh, do recomputation. So basically, if since it is initialized with the -1, if it is not the -1, then we have that answer memo n, and we need to change that here memo. First we need to save value of this, so no recomputation. C is missing, right? Okay, I will just go here and put C, and I will return this thing. And similarly I will just copy this and I will add here 1 and I will return memo. So that's it. Let's run the code. So it says -1. Actually we need to put memo in here. So it got passed. Let's submit the solution. Yeah, so submit is complete. So that's all for this problem.